Our next topic is testing of mobile applications. First, let me tell a couple of words about myself. My name is Victoria Slinevchuk. I live in Odessa, Ukraine. I am in testing from year 2005. I worked as test manager and as head of quality assurance and technical support department in a company named Shape. Then I worked at Luxoft Quality Center Automotive in Odessa, and now I work as trainer and technical translator at Luxoft Training Center. You may find me on LinkedIn. If you have any questions after presentation, then you may contact me, I will answer you. So let's start with our topic, how to test mobile applications and what is mobile app specifics, which we should take into consideration. First, let's look at most popular mobile platforms. When we talk about mobile apps, we first of all mean Android and iOS applications, because Android and iOS are market leaders now. Also, there is Windows Phone, but its market share is rather low. However, you may also need to test Windows Phone apps. I will mainly focus on Android and iOS apps, but most of the points are also applicable to Windows Phone applications. On this slide, you may see recent statistics collected by Net Market Share in February 2016, and you see that Android dominates the market with almost 60% of mobile devices having Android on them, and iOS has a little more than 30% of devices. Also, there are other minor shares of Symbian, BlackBerry, and so on. Windows Phone has about 2.5%. But you should remember that statistics differs from country to country. In some countries, iOS has larger share. For example, in the United States. And if you take India, for example, then you will see that there are even more Android phones there. One more interesting thing is that there are more iOS applications than Android applications in market. And also, iOS is a favorite platform for enterprise apps. Many companies that build their own apps, they prefer iOS. By the way, I think that you're also users of mobile applications, and you also use some smartphones. And I'd like to ask you, what operating system do you use on your personal device? Sorry. Windows Phone, iOS, Android, Windows Phone, Android, Windows Phone, iOS, Android, iOS, Android and iOS, Android, iOS, Android. Okay, I see that also Android dominates, and some people write that I test apps on all three. Quite a lot number of Windows Phone users I see here. Okay, so you're familiar with mobile operating systems from users' perspective, at least. That's great. So you understand what I'm talking about from your personal user's point of view. I also see a reply Windows Mobile. Do you mean some older device like Windows Mobile 6 or Windows Mobile 5? Okay, then let's go to the next slide. What are the differences between mobile operating systems and desktop operating systems? First of all, I'd like to say that there are more often updates on mobile. Mobile operating systems are updated more often. You may remember that we used, for example, Windows XP for maybe 10 years, and we're happy with it. Then another version arrived. But on mobile, for example, Apple releases one major update every year. Google releases slightly less often, but almost every year they release a new major update. And there are also some minor updates, which are more often. What we have as a result, that developers should support much older releases than available on your phones. For example, on Android, we have version 6 already, but many developers still continue supporting version 5 and also version 4. Why? Because many users still use these OS versions. It's a challenge for mobile testing because we have to test on different operating systems. Some of them are outdated, but we still have to support them. Then, one more difference is that mobile devices and mobile operating systems are touchscreen based. So mobile operating systems are tailored for this purpose. Touchscreen technology is also available on laptops, for example, and there are also displays for desktop PCs that also support touchscreen, but it's not mainstream. Some people use this, but it's not very common input interface. And on mobile, it's very popular. It's main input system. One more feature of mobile operating systems is so-called monotasking. It is more common for mobile. In Windows or on Mac, you usually have many applications running, and you see several windows on your screen, and you switch between them. Maybe you even divide your screen and see different apps at the same time and work with them simultaneously. But it's not common for mobile. On mobile, usually we have one app running at the screen. However, multi-window mode is already supported by the latest Android versions, but it's still not very common. So mobile OS, they are monotasking. Also, power saving features are traditionally more important for mobile platforms. Surely because mobile device, it is mobile, it cannot be constantly connected to electricity. So power saving is more important. However, it is also important for laptops, for example, for netbooks. So these features, power saving features, they migrate to desktop operating systems also. For example, Apple already brought some power saving features from mobile to desktop. They first tested them on iPhones, iPads, and then they put them to Mac. So the difference between mobile and desktop operating systems becomes smaller and smaller. We may see mutual enrichment of mobile and desktop operating systems. Sometimes also they say that there is not mobile operating system anymore. Maybe not everybody could agree with this, but it's kind of a trend now. And many companies, they aim to develop one operating system for all platforms. For example, Microsoft continues moving in this direction. Here you may see how Windows Phone home screen looks. It's very similar to what you see on your laptop or on your desktop. You see the same tiles, very similar interface. And Microsoft says that their aim is to streamline this 10th version of Windows from 3 operating systems into one single converged operating system for screens of all sizes. It's their official policy. 3 operating systems means Windows, Windows Phone, and Windows Embedded. So this trend shows us the differences between mobile and desktop become smaller and smaller, and we see bridging the gaps. So many things that I will tell you about testing mobile applications, they will be also applicable to testing usual desktop applications in future. Also, first of all, I'd like to start with such topic as mobile application users' expectations. Why? Because when we talk about quality, we need to understand what our users expect. What do they want? How do they see quality? What do they do when they encounter problems? And what kind of problems do they encounter? These data are taken from survey conducted by Dimensional Research in February 2015, about a year ago. This research was sponsored by Hewlett-Packard, and they have asked different questions to users from different countries with different mobile devices. There are some interesting results that can be useful for us as testers in order to understand what do our users expect. From first graph, you may see that users value application speed and responsiveness, which means performance. Nearly all users, 96%, stated that performance is important, and over 3/4 of users shared that it is very important or critically important. And what do they mean when we are talking about speed and responsiveness? What do they expect? On next diagram, you may see an answer to another question. In your opinion, how fast should an app respond? 61% expected applications to start in 4 seconds or less, and 49% expected apps to respond in 2 seconds or less. So very few users will wait for more than 4 seconds. In fact, you should make sure that the application starts within 2 seconds. For example, Google requires in their official guidelines to developers that if the application does not start in 2 seconds, there should be progress bar. So 2 seconds is the most acceptable time span, though some users can wait for some longer. Then, what is the frequency of problems? Here you may see the answers to some more questions. On average, how often do you experience issues with mobile apps? 20% of respondents indicated that they have app issues daily, every day. And 17% stated they have app problems weekly. That means that over a quarter of the market are having at least one app issue every week. Another 19% stated they have a problem at least once a month. So you may see that problems with the mobile apps are very common and many users encounter them. Then participants were asked about severe app issues, where the mobile app may have crashed, stopped working, or returned an error. Over the last 6 months, over half the users indicated that they had experienced a severe app issue. What happens then? What happens when the application crashes or stops responding or shows some unclear error? Users blame the application and the developer, as we may see from the results of this survey. Participants were asked what they thought was the cause of mobile app issues, and 55% placed the blame on the mobile app itself, which means that regardless of the actual cause, over half of all users will hold the app responsible. But in fact, there could be some other problem, mobile network or some problem with the phone, with operating system, and so on. But users tend to blame application and developer. So the companies that offer and develop mobile apps should expect the finger pointed at them more often, regardless of whether the app is really at fault or not. Also, mobile device users were asked if issues with the devices negatively reflected on their opinion of the company who made the app. And 37% of the users who experienced a mobile app that crashed or froze thought worse of the company that made application. And 36% of users who had experienced low performance issues also had a lower opinion of the company who developed the application. Other concerns were difficult to use apps, which means usability problems, and heavy battery usage also could be a reason why users think worse about the app and the company. Here we may see the main causes of customer dissatisfaction. Then participants were asked what actions they took with apps that had some severe issues, such as crashes, stopping responding, and producing errors. Most users, 53%, just uninstalled or removed the app completely, and 37% stopped using the app. 28% looked for an alternative application. The findings are quite clear. Companies that produce poor performing or buggy mobile apps will not see those apps used for long, which will result in lost customers and in lost revenue opportunity. The next question investigates how many chances a problematic app has before a user decides to abandon it. Participants' responses show that users don't have a lot of patience for mobile app issues. And 80% of users indicated that an app will get a maximum of 3 chances before they stop using it. So 3 strikes and you are out. You have only 2-3 attempts, not more. And more than half, 56% of users will only give an app 2 chances. And 6% will abandon it after first sign of some problem. What conclusions we can make from this? First of all, expectations are really high, and tolerance to performance issues, usability problems, crashes, and so on is very low. Low tolerance, high expectation. Poor user experience is likely to discourage users from using an app again. It also causes bad feedbacks in app stores. So what should we focus on? Performance, which is important, then avoiding crashes and errors, usability, battery usage. These are the main reasons of customer dissatisfaction. Also, it is very important to remember that first launch is extremely important. There should be not only no errors, but also the application should be usable. It should be clear what to do next, how to use the app. Because if user does not understand what to do, how to use, they will just close your app and never return to it again. Which topics will we discuss in this lecture? Usability and performance will be out of scope, and also battery usage. We will talk about avoiding crashes and errors first of all, because we have not too much time. We will focus just on this topic. Because describing all these topics within an hour is not possible. So we will talk about crashes and errors. Crashes first. Let's talk about crashes. Here you may see the scale of the problem. These data are taken from intelligent.com, which is a useful website with lots of statistics related to mobile operating systems. And here you may see how often do the applications crash on Android and on iOS. Here you may see that crashes depend on operating system version. For example, on iOS 7, apps crashes more often. And also you may see that iOS apps, they crash a little more often than Android apps. I see a question. A question from Ivan: how to test battery consuming by your app? Which results are expected? Sorry, this question is really out of scope. We cannot talk on this topic really. It's a separate topic which cannot be covered within this lecture. Okay, so let's go back to crashes. To understand these statistics, what do these percents mean? This means how many of application starts finish with crash. If it is about 3%, this means that if you start the app 100 times, it will crash 3 times. How to look for crashes? How to prevent them in release versions? Surely we should aim to detect crashes early during our testing, because crash is one of the most annoying faults from users' point of view. We often test some complicated scenarios, some boundary conditions, and so on, but users often suffer from very simple and annoying problems, like the app crashes. What should we do to avoid this? First, let's try to understand why the app crashes. Application crashes if it tries to perform some operation which is not allowed by operating system. For example, it could be an attempt to read or write inaccessible memory that has become damaged or that belongs to another process. Then, an attempt to perform input or output operations on hardware to which it does not have permission to access. Also, passing invalid arguments to system calls, or attempt to access other system resources to which the application does not have permission to access. Then attempt to execute machine instructions with bad arguments, like dividing by 0. All these situations could cause crashes. It is very important that the app send crash reports. Because in order to find out the reasons of crashes, you need to have logs. So make sure that your application sends crash reports. There are different crash analytics tools which help to support the app and implement fixes. I will tell about them once more a bit later, how they can be useful even after our testing. During our testing, they provide us detailed logs so that developers can troubleshoot the situation. How we may look for crashes? This list is not full. You may invent your own methods, but there are some ideas how you may do this. What can cause crashes? For example, tapping quickly on different areas on the screen. This technique is called monkey test. It can be automated. You should not do this manually. This could be automated. Then, changing device orientation. This also can cause crashes. Testing against changing network conditions. Losing connection, switching between Wi-Fi hotspots, and so on. Also, crashes often happen in such situations. We will also talk about testing connectivity a bit later. Then testing on low battery conditions can also cause crashes. For some reason, really I don't know why, but apps crash more often when battery is low. One more idea to detect crashes is to leave the application running for some long time period, for example, for 24 hours or for 12 hours at least. When you leave the office in the evening, you may leave your application running, and in the morning you may see what happened. it's not very usual test because on mobile we usually use the application for some short time periods. We just open the app, do something, and go to the next app. But long run tests could also be useful. Also, one more idea is to test with many other applications running in background. Make your testing realistic. If you just do your tests, you may just run your own application and test it, but your real users, they will have a lot of apps on their device, and they will run multiple applications in background, so memory will be limited. Testing in such conditions also helps to detect crashes. Load testing. What do I mean here by load testing? For example, loading a large number of elements, scrolling through some long list. If you have some list in your app, like contact list, pictures gallery, and so on, you may try to create a long list, long galleries, and using such long lists may cause crashes, and you may detect them by such tests. Also, sending and receiving large amount of data. For example, a bunch of messages, or downloading and uploading large files, and so on. Sorry. But this list is not full. You will also encounter crashes in different situations. Sometimes it will be difficult to find out which actions lead to the crashes. That's why it is important to collect crash reports. Here are some tools. There are more tools which allow to collect crash logs. I may recommend Flurry, Criticism, and Bugsense, or you may find your own. This will also help you to maintain your app in future, because I can tell you from my own experience that you will not detect all crashes during testing. Unfortunately, that's not possible. Your app will crash. Your app will crash anyway with your users. But you should do something with this. How can you fix these bugs? You may only do this if you have some information. Flurry, Criticism, and so on, they provide libraries that could be included into your application. They are very lightweight. They are quite secure, and many developers use them. They will gather anonymous statistics from your users, and you will know when your app crashes on real devices of your users. Also, I may tell you from my own experience that at least one in 7-8 releases will cause very intensive crashes on your users' devices, and you will have to apply some hot fixes in order to save the situation. This is a really serious problem that will arise if you develop and test mobile apps. So I really recommend you to apply such countermeasures beforehand. Do not wait until you encounter such situation. Add something like Flurry to your app and start gathering reports. This will really help you. Okay, that's all I wanted to say about crashes. And what about different errors and some situations that may cause severe issues with your app? Surely you should test your app according to your specifications, to your user stories that you have, or any other documentation. As you are all testers, I should not tell you that you should test your app's features. Surely you should do this. But also you should remember about mobile platform specific and include some mobile specific tests to your test cases, to your test scenarios. And first of all, I'd like to say about interruptions. You should remember about different interruptions that your users will encounter. You may write your user stories, test scenarios in such a straightforward way, like your user starts your app and goes from point A to point B, making some steps one by one. But in fact, in real life, this will not be so. In fact, your user's workflow will be interrupted. This comes from specifics of mobile phone, mobile device usage. You need to include such interruptions into your scenarios to make sure that your app functions properly if something happens outside of the app. What situations should be included into your test scenarios? For example, it's incoming SMS messages. What will happen to your app when a user receives SMS message, for example? Or if incoming call appears. One more idea is battery pooling. You know, it's not possible on iPhone, but on Android it's really common. As you may know, that it's a popular solution to reboot device if something went wrong. On Windows, for example, many users do this. If something is wrong, just reboot. Also, mobile users do the same, and they reboot their device by pulling battery. This may happen when your application is working. And you should make sure that next time your app is started, it functions correctly, that all settings are saved, and so on. The app should reconnect, settings and status should be set. Also, connecting and disconnecting USB cable could happen during your application function, or charging the device. And also various network events. Also on Android, user may mount or dismount SD card. On some phones, it's even possible to mount or dismount SD card without pulling the battery out. So device is working and SD card is inserted. Then, as many users use their phones for listening music, you should make sure that your application works properly with a music player. What happens if a music player is working and your application is started, especially if your application has its own sound notifications? I have a question from Ivan. Please give examples for various network events. A bit later, we will talk about this. About connectivity, there will be a separate slide. Then, incoming push messages from other apps. Not only your application gets push messages, but also your application may receive, it will not receive these push messages, but they may come while your application is functioning. And you should make sure that after reading this push message, your app continues functioning properly. Also, a useful test is to let the device go to sleep mode. I know that often testers, and I do this myself, just disable sleep mode when making tests because it's more convenient. But you should at least try how it will work with your app. Let your device go to sleep mode and then wake it and return to your app and see what will happen. So the app should react on different interruptions properly. When phone call comes, for example, then there are some rules provided by operating system developers. For example, if phone call comes, then game or video playback should be paused. It's normal behavior. You should make sure that your application complies to such standards. Then some more mobile-specific tests. Screen rotation. Perhaps you're used to using your device in portrait mode, but there is also landscape mode, and many people they use both modes, and you should check this obligatory. How UI refreshes, because it often happens that such black squares appear on the screen. UI refreshes not properly, and this also can cause crashes. Then background and multitasking mode. Background and multitasking mode works differently on iOS and on Android. It looks very similar, but technically it's different, and you should understand how it works and test your device in these modes. Then how your application reacts on accelerometer and motion sensor. It means when you move, you should test on the go, not just sitting near your desk. You should move because your real users, they will move. They will use transport. They will go by bus, by car. They will walk and do something on their devices and so on. Also, push. I think as your mobile devices users, you should know what push is. So you also, if your app uses push notifications, you should test this feature. Then using your application with different accessories. Here you need to make a wise choice with which accessories to test your app. It depends on your app functionality. There are a lot of different accessories. For example, Bluetooth keyboard or Bluetooth headset, and so on. You should understand with which accessories your app will be used. For example, if your application requires intensive text input, then it's very likely that it will be used with Bluetooth keyboard, and you should test it. If your application is not intended for text editing, for example, it's a game, it's not very likely that it will be used with a Bluetooth keyboard. But if you develop a text editor or messenger, it could be used with Bluetooth keyboard, and you should test this. If you do not test this, you can be sure that it will work. The same as with a headset. If your application works with audio and video, you should test it. Maybe if it is a game, also you should test how audio works. In other cases, maybe it's not so important. So you should select, depending on your application functionality, with which accessories it should be tested. Then it's important to test with different start conditions. First start is very important, and we talked about this already. Starting from background, starting after device reboot, starting after crash. And on Android, there are also widgets. If your application has widgets, you should test start from each widget separately, because many problems may arise here. Also, important thing is notifications. There are different notifications: sound, vibro, push alerts. Also, notifications should be depending on profile. If your phone is in silent mode, your app should not make noise. Also, make sure that your notifications are synchronized, because not synchronized notifications are annoying. If first vibro comes and then in 2 seconds sound comes, people do not understand what does this mean. Also, I have a question from Ivan. Lock screen and sleep mode, is it similar? I've heard that Android OS has a deep sleep after 15 minutes of screen lock or something like that. I think it could be different cases. When you lock screen just pressing a button, or when it goes to sleep mode by itself. These situations are different. They're not the same. Then about connectivity, I have mentioned some network events with which you would need to test your app. About connectivity, almost every app nowadays uses internet connection somehow, but for some applications it is more important than for others. If you develop Messenger, then connectivity is crucial for your app. For some other apps, it's not very important. So you should decide how thoroughly to test connectivity depending on your app specifics. But here I suppose that connectivity is important and try to describe as lot as possible different options. First of all, you need to test on both Wi-Fi and mobile operator network. Results could vary. Also, some potentially wrong situations could be when you switch between Wi-Fi 3G and 3G Wi-Fi. This situation is also need to be tested. Also, testing on earlier generations networks is important if there is an if your app will be used in countries where earlier generations networks are widespread. For example, if your target audience is located in Western Europe, most likely you will not need to test on earlier generations networks. But if your target audience is in, for example, India, maybe you should test on earlier generation networks. It depends on your target audience. But if you have reasons to think that your target audience will use earlier generations network, don't suppose that it will work properly on them if you have tested it on 3G. Maybe it will not work properly. Also, many network events appear when users move. For example, when you go by bus or by car, you switch between cell towers. And in this situation, your app may lose connection for some second, or maybe for some less than second. How your app will handle this? Will it show the error message, or will it not show the error message? Should it reconnect? Perhaps it should reconnect. Maybe it should show error message, or maybe it shouldn't show error message. It depends on your specifications and how you treat the situation. Also, you may know that when you go in underground, you may lose connection. Such situations also are worth testing. Network access errors could be different. For example, no signal when you are in some area where you do not have wireless carrier coverage. Or sometimes you may have situation when there are no money on user's account, and you cannot access internet for this reason. Then network could be interrupted for some time and then restored. Your application should react properly, should restore connection. So when network error occurs, your app should show appropriate error message, and it should allow other functions which do not require internet connection. And then, after connection is restored, your application should also restore connection. And such situations are common in real life. If you go with your smartphone around the city, and especially if you go in the country, if you go outside of the city, if you travel by train, you will encounter various network interruptions. How to reproduce such situations in your office? I understand that you cannot travel by train in order to test your app. There are several hints how to do this. For example, you may place device to steal safe, and the safe is a metal box. It will screen your device from network, and you will emulate losing connection. Or you may use aluminum foil to make your device lose signal. It's also an option. Also, you may try to use the application in elevator. Elevator is also a metal box, and you often lose signal when you are in elevator. It's a test that you may easily do in any office building. One more test that you may make with your app is airplane mode. There is an option to turn on and turn off airplane mode. It's a setting available on most of mobile devices. It suspends signal transmitting functions, including internet connection. It's a very good test to enable airplane mode and check how your app behaves. And then disable airplane mode and see how your application reconnects. Also, there are some additional tools that allow to emulate different network conditions. For example, for iOS, in developer setting of iPhone or iPad device, you must see network link conditioner. It is on screenshot. And here you may emulate different network conditions, like very bad network, or high latency DNS, or 100% loss of signal, and so on. In fact, it's an emulation. It's not a real network condition, but you may use it also for your testing purposes. Some more words about testing connectivity and about Wi-Fi. It's always better to test on real Wi-Fi spots, in restaurants, on streets, in airports, and so on. Real Wi-Fi network, they differ from your nice office Wi-Fi. They are often overloaded and they have low signal. So user experience differs from Wi-Fi spot you usually have at office. So avoid testing only in an ivory tower, in your perfect testing conditions. You may test on different Wi-Fi signal strength and see how your application behaves. Perhaps it can start to throw a lot of connection-disconnection errors, which is bad. Testing on different Wi-Fi signal strength, you may easily do it in your office, just going in different rooms and finding some places where Wi-Fi signal is weak. Also switching between hotspots. Usually it's also possible in office because you may have several Wi-Fi hotspots in your office. And you may check your application behavior in such conditions. Some Wi-Fi networks require web authentication. Users should open a browser and make some actions in order to connect. This requires additional testing, how your application will behave. Sometimes this also cause errors. Also, there are proxied Wi-Fi networks. Why it's worth testing separately is because when using proxy, the application receives different error messages, different from usual. They are 500 series, 513, 520, and so on. They're different from timeouts and from regular failures, and your app may react differently on such error messages. Also, some free Wi-Fi networks, they have time limitation. This is also one more situation which you may test with your app. What happens when time limit has expired? You may imagine many different situations related to connectivity. If it is worth to test all these situations with your app, it depends on your app. If it uses internet connection, very often, if connectivity is important, you should test as more as possible situations to see how your app will behave on real devices in real conditions with your users. If it does not use connectivity very much, then you may just test some basic situations. Personally, I tested the app which was Messenger, and connectivity was crucial. Connectivity was the main part of functionality. So I had to dig deeply into this topic. What else is important when you test your mobile app is to test interaction. Testing interoperability with other apps. The specific of mobile platform is that apps usually interact with one another. For example, your application may interact with social network applications, with Facebook, for example, with Twitter, with mail apps, with browser, with the contacts, and so on. You should find out with which apps your application interact and test this part of your application functionality. There could be different situations. For example, on Android, it is possible to change default browser or default mail application. And if your Android app interacts with the browser or email, you should check this situation, what happens when default browser or mail is changed. Sometimes it may happen that required applications are not installed. If your app works with some apps that are that could be not installed, you should check what happens then. Also, you should not only check that your app interacts with other apps, but also that it interacts properly. For example, that arguments are passed to appropriate fields. For example, there is such feature that user may press some button to recommend your app to other person. You have a button, recommend a friend, and then mail app opens and the user writes an email. So you should pass, for example, topic, argument to topic, and email to email. Make sure that arguments are passed properly. If your application interacts with contacts, there could be also different behaviors when different types of synchronization is enabled on device. You know that you may synchronize your contacts, for example, with Google or with iCloud, and the behavior of your application may vary. I have encountered such situation when testing business card reader application. Business card reader, it allowed to make a photo of business card, then recognize it using OCR, and then save this information into contact section. So it interacted with contacts of mobile device, and the behavior of application was different when no synchronization was enabled, when Google synchronization was enabled, and when iCloud synchronization was enabled. And there were a lot of defects caused by a specific type of synchronization. So find out with what apps your app may interact and test this interaction properly. And some general recommendations for testing mobile apps, some summary. First of all, you should avoid testing in ivory tower. Remember that your users will use your app in real conditions, maybe with poor network, with different Wi-Fi hotspots, moving on the go, maybe in bus, in car, and so on. So remember that you should test in realistic conditions. Then, whenever possible, test on real devices. Testing on emulators is convenient. It allows to get good logs and so on, but your users will use real device, and it's better to test on real device. Also, you need to understand platform specifics. How push works on iOS and on Android, how background mode, multitasking work, platform-specific gestures, and so on. It's also nice to have a real user experience with a mobile platform. If you have real user experience, you may make your tests more realistic. If it's the first time you have a device in your hands, it will be very difficult for you to test your app on this device. Then, where possible, apply automation, but do not rely on automation only. There's always non-heuristic component in mobile testing. Usability is also important, and you cannot assess usability by automation tools. You should have your experience with your hands, in fact. make real gestures like your users do. Have device in your hand, because it's this sensor experience, it's very important for your users. If you do not know how to locate buttons, how buttons should be located, or how this or that should react, you may compare to default apps. If you're not sure, check how it works in browser, in mail application, in some pre-installed apps on this specific platform. And also you may use different guidelines provided by Apple, by Google. They also have guidelines for developers, how UI should look, and so on. Use guidelines also. So here we have only 1 hour for a short introduction, but I also have a longer special training course about mobile application testing. It lasts for 8 hours, and Luxoft Training Center offers this course. If you are interested in more detailed discussion of this topic of mobile application testing, you may visit this course and find out more interesting things about mobile apps and how to test them. If you have any questions, I'm ready to answer. I have a question from Anton. What tools do you use for testing, for automation? Do you use emulators? Possibly you can advise the best of them. Thanks. As for emulators are part of Android SDK and of Apple developers tools. So do not look for other emulators. There are also different emulators for Android, but I do not recommend them. Use the emulators that Apple and Google provide. They are the best. For automation, as for me, I have not very successful results from for automation of mobile testing, because I encountered such situation. Application constantly changes. It's very dynamic. Interface changes, and because of these changes, we had to change this test too often. It was not practical for me. So as for automation tools, there are lots of them, really. This topic is covered in longer training. There are various frameworks for automation testing, but as for me, I cannot recommend you the best choice here. I have not very good experience with automation of mobile tests. I have a question. How much time does it usually take to test one not very complicated mobile app? How many days, weeks? Very abstract question, in fact. What is not very complicated, and what kind of testing do you mean? In fact, I never had more than 2 weeks of testing, just because of time limitations. Not more than 2 weeks. I have never been given more time, and 2 weeks was maximum. In fact, usually I had to test an app with one more person, so 2 testers, and about 2-3 days. Here I do not mean first release. I do not mean first release. I mean that you have an application and from time to time you update it and you need to test new update. As for first release, sure, development takes some time. It takes some months, and during this development, testers also participate and test from time to time. Also, I have a question from Katarzyna. Which of the programs you recommended, Flurry, etc., is best for beginners? First of all, I'd like to tell you that implementing Flurry is your developer's task. You will not do this by yourself. It will help you, but you first have to discuss this with your developers. And there should be their choice what is better for them. For you, I think it's not very important for you which tool to select. I'd recommend you to talk with your development team and discuss with them. Let them select what they like, what they prefer. Also a question from Ivan, how to test battery consuming by your app, which results are expected? It's a difficult question really, because there are no exact threshold meanings. You should compare to something. Compare to what? You may compare, for example, to previous versions of your application. If you notice that some newer version causes more battery drain, then there is some problem. Also, if you have a first version and you do not have previous releases to compare, you may compare to your competitors' apps. Take similar game or similar app, whatever you develop. Check how it uses battery, and then check your app and compare. If you see that your app uses much more, then there is some problem. If it is approximately similar, then that's okay. One more question. Thank you for presentation. What analytics system do you use on the project? If you use Google Analytics, how do you test analytics implementation, Margaret? Sorry, I don't understand what you mean by test analytics implementation. How should I test analytics implementation? Then, what is the environment for testing apps? Do you test it in some simulator rooms in workplace, or do you test it during free time out of work? Personally, I test on when I go by bus to my work, to my office. I start testing in public transport, really. That's what I do. And in office, I can use, for example, such tricks like placing device into safe or using the app in elevator and so on. So I think that mobile testers should test constantly. I tested on my home Wi-Fi and on my way to the office and in office to have some real situations which users will encounter. And when I went to business trip, I tested in airport on airport Wi-Fi to see how our users live with with such Wi-Fi hotspot, and found some defects when testing on airport Wi-Fi. So I use every opportunity. It's a lifestyle. As for analytics, if you mean, for example, crash logs analytics, I recommend Flurry. I recommend it because in my situation, in my project, developers used it very successfully and they were satisfied. And we also were satisfied because they fixed defects related to crashes very quickly and effectively. Question: what is about Crashlytics? I have not tried it. If you like it, you may try. There are a lot of tools. I have not tried all of them, but you may select with your developers whatever you like. A question from Metro. Thank you very much. It was very helpful. Could you share your PowerPoint presentation? As for presentation, I think that organizers will send you. We might ask organizers. Will the presentations be sent to participants?
Colleagues, Victoria, if you allow, we can share your presentation after the conference.
Okay, I'm okay with this.
Okay, colleagues, when we prepare a video, we send you mail about with links to the video of presentations.
One more question. Oh, I see one more question.
Okay, sorry, I'm mute.
SQA 40 training, when and where it will be held? Next training will be online in the beginning of June. You may join online training, and if you would like to participate in this training offline in your location, contact Luxoft Training Center and order this training. I can deliver it in different cities. I have already delivered them in Odessa, in Bucharest, in Sofia. So it's up on you. I have a question from Pavel. Which mobile operating systems is according to your future? In fact, I cannot predict this. I do not predict future. It's not my profession. In fact, I see that there are no real competitors to Android and iOS. I do not think that some new operating system will appear soon. But I cannot guarantee this. Nobody has expected iOS, for example. Nobody knew that it will appear, but it appeared. Maybe something new will appear. Who knows? I cannot predict this. At the moment, Android and iOS are market leaders. I think this will not change, at least within next 2-3 years. But maybe it will change. Who knows? A question from Gregor. So you don't consider Windows Phone to last? Windows Phone, maybe it will last. It exists and some people use it, and it is supported by very, very popular desktop operating system, Windows. So some people will use it, but at the moment you may see that Windows Phone was not able to be a real competition to Android and iOS. It has not become a market leader. And I don't think that it will become a leader on the market. But in fact, I cannot guarantee. I do not predict future. Also, I have a question from Michal. What is the way of reporting failures, defects? Do you test app with emulators and, for example, after a week you give reports to programmers? How does the relation between you and programmer looks? The defects are posted immediately into Jira, and the developers start to analyze them without waiting to full report. So in my practice, testing is very interactive, and developers do not wait until final reports. They start working with defects as soon as they appear in bug tracking system. But it doesn't. This doesn't relate to mobile apps or any other app. It depends on your internal QA process, how it is organized in your company. So you may use the same procedures you use for testing web applications or Windows applications. It doesn't matter.
Colleagues, I think it's all questions. Victoria, thank you so much for your presentation.
Thank you all.